Proof of Heron's formula. We all know that this formula used in computing the area of a triangle given the three sides of it, where S is A plus B plus C over 2, or the semi-perimeter. So now we consider a triangle. With height H and points A, B, and C. And we call this point here point D, with sides A, B, and C. So, okay, we call this X, AD, and this is C minus X, DB. Okay, so now in triangle ADC, using Pythagorean theorem, we have b squared is equals to x squared plus h squared. So h squared is equals to b squared minus x squared. This will be our equation 1. Now in triangle BDC, using Pythagorean again, so we have a squared is equals to c minus x squared plus h squared. So computing for h squared, we have a squared minus c minus x squared will be our equation 2. Now, since equation 1 and equation 2 are equal, so we can equate 1 and 2, equation 1 and 2. So equation 1 is equals to equation 2. So b squared minus x squared is equals to a squared minus c minus x squared. Okay. So we continue. B squared minus x squared is equals to squared minus c squared minus 2cx plus x squared. Okay, so b squared minus x squared is equals to a squared minus c squared plus 2cx minus x squared. So this one and this one we can cancel out from the equation. So we compute for the value of x. So x is equals to b squared minus a squared plus c squared over 2c. This will be our equation 3. Okay, now in triangle ABC, so we have triangle ABC. So in triangle ABC, we know that the area of the triangle is equals to 1/2 base times height. But our base from the figure, base is equals to c, and from equation 1, we get the value of h. So h squared is equals to b squared minus x squared. So h will be equal to square root of b squared minus x squared. Okay, so this one and this one we substitute here. So So our equation will be 1/2 c times the square root of b squared minus x squared. Okay, so we continue. Then we substitute the value of x here. So our x is this one. We substitute here. So a area is equals to 1/2 c b squared minus, so we have the x squared here. So but our x is equals to b squared minus a squared plus c squared over 2c. Okay, and then we continue. So from here we can take the common denominator of the two terms inside the radical sign, and that is 4c squared. So now area will be so I will multiply b squared by 4c squared over 4c squared. So minus b squared minus a squared plus c squared, and then over 4c squared. Okay, and then we factor out the common denominator inside the radical sign. So a is equals to, let's see, square root. So that is 1 over 4c squared. Okay, so I will rewrite this b squared times 4 times c squared to look like this. 2bc and then squared. Okay, minus squared minus a squared plus c squared and then squared. Okay, and then we try to bring this term here outside the radical sign inside. Okay, so but we have to take note that c is equals to 1/4 c squared. Okay, so a is equals to, so we can cancel out c squared, so we have 1 over 16 1 over 16 2bc squared minus b squared minus a squared. Okay, yeah, okay. Now from the difference of two squares, you will notice that this and this is actually our first and second term. Okay, so from difference of two squares, we have x squared minus y squared is equals to x minus y squared, x plus y squared. Okay, so our first term will be our x and the second term will be our y. Okay, and then we perform. So a is equals to 1/16. Okay, yeah. X to BC minus b squared minus a squared plus c squared. Okay, so this will be our x minus y, and then multiplied by 2bc plus b squared minus a squared plus c squared. Okay, so then don't forget the radical sign. Okay, so from here we can further simplify this term. So we notice that we can factor out using this, and this here, this, B and C. Okay, so 2bc minus b squared minus a squared, plus a squared minus c squared. Okay, so we combine what we need to obtain the factoring. So a squared minus b squared plus 2bc minus c squared. Factor out the negative sign. So a squared minus b squared minus 2bc plus c squared. And then a squared minus, this will become b minus c and then squared. Okay, and then here we combine what we need. So b squared plus 2bc plus c squared minus a squared. So this one here will become b plus c squared minus a squared. Okay, so our a will become 1/16 multiplied by a squared minus squared, and then by b plus c squared minus a squared, radical sign. Okay, and then we can apply again the difference of the square, because here is our first term, here is our second term, here is our first term, and here is our second term. Okay, so we perform again the difference of two squares. So a is equals to 1/16 times A minus B minus C. This will be our X and this will be our Y. Here, this will be our X, this will be our Y. So we focus on this term. So then A plus B minus C. Okay, and then we go to the next one. So this is B plus C minus A, and then B plus C plus A. Okay, so and then the radical sign, square root. Okay, so we distribute the 1/16 in each close in bracket. So this is our 1, 2, 3, 4. So we need to distribute this into 4. So note that 1/16 is equals to 1/2, 1/2 times 1/2 times 1/2. Okay, so we can put 2 as denominator in each bracket. So we do that. So A is equals to, this one is actually A minus B plus C. So A minus B plus C, and then we put the denominator 2. Okay, then times A plus B minus C, A plus B minus C, and then B plus C minus A, B plus C minus A, and then B plus C or ABC plus A/2. Okay, it's okay. So we take note that S, or we let S is equals to A plus B plus C/2. Okay, so from here this is okay. So if our S is equals to A plus B plus 2/2, then this one here, or this one, so A plus B minus C/2 is actually equals to A plus B plus C/2 minus C. We put 2 here, we put 2 here. Okay, so C minus 2, or 1 minus 2, will give you negative C. So this term here is actually our S. So this will become S minus C. Okay, same thing happens with others. So let's say this one. So A minus B plus C over 2 is equals to A plus B plus C over 2 minus B. Okay, we put 2 here, we put 2 here. Okay, so this will become S minus B. And then the other one, this one here, B plus C minus A over 2 is equals to A plus B plus C over 2 minus A. We put 2 here, we put 2 here. So 1 minus 2 will give you negative A. So this will become S minus A. Okay, and finally, the last one here, the last one, so 1, 2, and the last one, B plus C plus A over 2 is actually our S, right? Remember, we let S equals to A plus B plus C over 2. Okay, so this is, then we substitute this on back to our equation. So our equation, we have A, wait, I will copy first, right? So A is equals to A minus B plus C over 2, and then A plus B minus C over 2, and then B plus C over A 2, and then B plus C plus A over 2 square root. Okay, and then we replace each term here with this one. Okay, so A is equals to, what is A minus B plus C in number 2? That is S minus B, and this one will be S minus C here. So S minus C. This one will be S minus A, and this one our S. So rearranging, we have S times S minus A times S minus B times S minus C. So this is actually our Heron's formula. Okay? Wait. Okay, that's it.